So today we're going to talk about weather forecasting a little bit more, talking about air pressure patterns, high and low pressure systems, as well as how we measure different things regarding the weather in order to forecast it. So the first part that you fill in here is on different weather tools that are available to meteorologists. We have our trusty thermometer measuring air temperature in either Celsius or Fahrenheit usually. Then we have a tool here that looks like a couple spinning cups on a rod. That's known as an anemometer. It measures wind speed. The tool here is called a hygrometer that measures the humidity or water content, moisture in the air. Down here, a little tricky to see, but this is called a rain gauge. It'll tell you how much rain has been received in a certain area over a period of time. This tells you wind direction, which way the wind is coming from and blowing towards. That's called a wind vane. And then finally here is a barometer. This measures changes in air pressure. And that air pressure can have a big impact on the weather that you experience in a certain area. So speaking of measuring pressure, that is going to bring us into our short discussion on isobars. So previously we talked about isotherms, which were lines on a weather map that separated areas of colder temperatures from warmer temperatures. Well, now the main difference here is that instead of talking about temperatures, now we're talking about pressures. That's where the bar from barometer comes in. So isobars are lines on a weather map that separate areas of lower air pressure from areas of higher air pressure. A big difference here is that these lines go up and down in 4, and the unit here is MB, which is going to stand for millibars. They go up in 4 millibar increments. So they don't go up and down by tens, just like the isotherms do. They go up and down by 4s. And I would say an easy isobar to remember as kind of a rough starting point, figuring out where your high and low pressure is 1,000 millibars. That's typically a pressure that you're going to see somewhere on a weather map at any given point if you zoom out enough. So 1,000 millibars is a good place to start, and then you can go up or down very easily. The math is pretty simple, going up or down in 4 millibar increments. But that's basically what you're doing. You're isolating these different areas, trying to identify where the high pressure zone or zones, depending on the weather systems moving through, and where the low pressure zone or zones are located on the map, because those are really going to influence a lot of things, including movement of air, what we would call wind, as well as cloud cover and possible precipitation. There's a lot that is dictated by barometric pressure, either going up or holding steady or going down in some cases. So these are kind of the kind of summary notes for different types of pressure system. You have your high pressure system. The air generally around a high moves out because you have excess air pressure, so it wants to give that air up, some of it at least, and kind of fill in the gaps in the surrounding low pressure zones. So it goes out. Over time it goes down because that mountain of air is ever diminishing as that air is given up to surrounding low pressure zones. And because of the Coriolis effect, it moves clockwise here in the northern hemisphere. And all those things put together make it very, very difficult for clouds to form because you have this continuously dropping air. It's getting closer to the Earth, so relatively speaking, it's going to warm up. And warmer air has a higher ability or greater ability to hold more moisture. So when we compare that or contrast that with the low pressure system, everything is basically the opposite. In a low, you kind of have this somewhat lack of air. You have air, but it is at a much lower pressure, so there's less air molecules in a given area. And over time, that air pressure is going to go slowly up as it's fed by the surrounding high pressure zones. And because of that Coriolis effect, it moves counterclockwise. In a low pressure zone, because you're piling air up over time and forcing the air that's there to move ever upwards into the colder areas of the troposphere, you're going to find it very, very easy to form clouds, and many of them, in the heart of a low pressure zone. So typically when you have a low pressure zone, that's often associated with, at a minimum, cloudy skies, but more often than not, you're also going to get some precipitation as well. Whether it's rain or snow kind of depends, or some combination of the two, depends on the air temperature. But the more clouds you make, the more likely it is that you're going to get a version of precipitation around a low. So there's something called a hand twist model to help you remember what's going on inside of a high pressure system and a low pressure system. So basically I'll just have to describe it since I can't really show it very well here. With the high pressure system, you can take your left or right hand, doesn't matter, but you start with all your fingers together and you put all those fingers on something like a tabletop. Then you're going to spin your hand around clockwise, so the same way that the hands on a clock move. And while you're spinning your hand around, you're going to spread your fingers out. And notice what happens with your palm. Your palm, as you spread your fingers out, will drop down closer to the table as you move your fingers out and you spin clockwise. That is the same kind of things that are happening to a high pressure system. As it moves through, it's spreading that air out. The high pressure air is dropping closer down towards the earth, and because of that, you're not putting all the ingredients together to make clouds. So usually in a high pressure system, you don't notice much, if any, clouds whatsoever. In a low pressure system, it's exactly the opposite. So for this hand twist model, you actually start with your palm totally flat and your fingers all spread out. Again, left or right hand, doesn't matter. But as you twist now counterclockwise, you're going to draw your fingers in closer to one another, and notice what happens to your palm as you do that. You're going to see your palm rise off the table, just like that rising parcel of air. And that parcel of air in the real troposphere is going to be cooling off and condensing into more and more clouds. So low pressure systems oftentimes associated with thicker cloud cover, and often precipitation as well, because the more clouds you have, the more likely it is that you're going to condense larger and larger crystals or droplets, and then that form of water is going to fall out of those clouds down to the ground, and that's precipitation. So in addition to some of the tools that I mentioned before and some things that are true about high and low pressure zones, there's also some other weather data, more technologically advanced information that comes from weather stations spread all throughout the nation and the world, weather balloons to figure out what's going on in upper areas of Earth's atmosphere, as well as weather satellites that are in orbit around Earth, and they're constantly looking back, looking at things like moisture content and air movement and pressure movement, things like that, and then weather radar as well. So we can look at things here down at the ground, we can look at things far above and try and get a better picture of what's going on with our changing weather, and hopefully get a clearer idea of what might happen, at least in the near future, as we forecast the weather.